here is an example of a weak base with a strong acid at the equivalence point. The Kb of our particular base is 5 times 10 to the minus 4th. And here's the equation. Our weak base plus the strong acid makes this plus that. And the given amount was 0.13 molar of the weak base and 0.13 molar of the strong acid, and the volume was 0.05 liters and 0.05 liters. If the molarities are the same, the volume has to be the same. We multiply the molarity times the volume to get the moles for each one, and they are equal because they're at the equivalence point. And then we take that number, since we subtracted it from the left-hand side, we will add it to the right-hand side. And then that leads us to step number 7, where we need to rewrite the equation. And we have this plus water makes this plus that. And then we take the moles that came from up here, and then we divide it by the total volume, which is 0.05 plus 0.05. And then we have x for this one and x for that one. And so we need to have our equilibrium expression. We were given Kb, but we need Ka because we're talking about acid here. So we do 1e minus 14 divided by 5e minus 4, and we get this for our Ka. And then we plug it into our equilibrium expression. So 2e minus 11 equals x squared divided by 0.065. It's that number right there. And then we solve for x, and the x is the amount of acid or H plus concentration. Then we plug it into pH. pH equals the negative log of that number, and the pH is 5.94. We go back to the beginning and we have a weak base and a strong acid. It makes sense that the pH is below 7 or in the acidic range, because when we have a strong acid and a weak base titrated, the equivalence point is below 7. I hope this was helpful.